Welcome to SourceCAD. In this video, Paul Mohindi will show you the step-by-step method of generating your quantity takeoffs with Civil 3D and then setting up your Civil 3D project, and finally you'll learn to generate detailed quantity takeoff reports. So with that, let's get started.
My name is Paul Mohindi. I'm a civil, structural, and planning engineer, and in this video, I'll be taking you through how to generate your quantity takeoff using the Autodesk Civil 3D. And for our case, we'll be using the 2023 version. If you're interested on sharpening your skills as an engineer, make sure to check out the course that I have linked down in the description, where we have gone into great detail on how to create your designs, especially road designs. If you want to know how to create your intersections, how to create your alignments, how to create your vertical alignments, how to become that engineer that you know you deserve, make sure to check out that amazing course that we have. So in this video, we'll be diving deep into the world of the civil engineers, and we'll be exploring on how the efficient calculation of quantities is usually done, and I can employ you to ensure that you use this technique that you'll be learning on your projects. As you're aware, in today's competitive construction industry, accurate quantity takeoff is crucial for estimating costs, planning resources, and ultimately delivering your project as a success. So whether you're a continuous professional or you're just getting started, mastering quantity takeoff techniques will greatly enhance your capabilities as a civil engineer. So throughout this tutorial, we will cover everything you need to know to become proficient in quantity takeoff using Civil 3D. From setting up your project to generating detailed reports, we will walk you through each step of the process. So having said that, the first thing that we actually have to do is to check our data. So the way we actually do this, assuming that our surveyor has sent this data to us, we first have to open our data. Much of the time, you'll find that the surveyor will send this data to you as an engineer in the Microsoft Excel worksheet. So I'm going to simply open this document up, and just like this is the way the document looks, where we have our points. So basically the PENZD points, which I've actually shared this document with you so that you can be able to follow along and be able to practice. So we have the P being the points, the E being the easting, N being the northing, the Z being the elevation, while the D being the description. So if you're interested to understand what these descriptions mean, I've also attached this document, which you can actually go through to understand what each and every single description key means. Not only that, it's crucial for you to always communicate with your surveyor team just to make sure that you be using the same description keys. When they go to the site, they do not use something different for the road edge. Maybe some of the surveyors use RD, some of them use RE, so just to harmonize the data. So I'm going to drop this and just back in our Excel workbook. So we first need to check out our data, what we have and what we need. So we can clearly see that we have some data, some of them being in 1 decimal places, some being in 2 decimal places. So that is actually something that we need to harmonize. And the way we're going to do this, we have actually to do away with this specific row. So it was good that the surveyor gave us this row just to give us a breakdown of what we have down here. But if you try actually to, let's say, add the decimal points, as we have this row, we'll be given an error and no points can be added. So we first need to do away with this row, select it, right click, navigate to delete. Then we're going to select these 3 rows, which is actually the easting, the northing, and the elevation, and we want to add them to the 3rd decimal place, just like that. So all of them are in 3 decimal places. So we have a hashtag error here because they're not fitting. So just select it, double click here the center, and just like that, all the data is now looking good. After doing that, we're going to simply export this data that we have here as a different file format. So we're going to simply navigate to File. We're going to go to Save As. You're going to specify the folder that you want to save that file in. So this one we have, let's say, refined. So it depends on what you want to save. And then we're going to change the type to actually comma delimited. So this is a file format that Civil 3D can be able to open. I'm going to click on Save Once. And just like that, now we have it saved. So we're going to get this warning here that might lose some data or some features, not an issue. Just click on yes. I'm going to simply click on close, then click on save, click on yes again, and that's it. Make sure to close from that specific file that you've saved. After that, I'm going to simply drop down and I'm going to navigate now to our Civil 3D. So the next thing that we're going to do, we're going to create a new project. So in this case, we'll be using a certain template that I have already created, and I will share it with you so that you can actually use it because I have the description keys already defined. So if you're interested on how we create all these description keys, I have linked down in the description a complete course, free course that you can actually use to learn on how to become a proficient Civil 3D user. So click on this once, and just like that, our Autodesk Civil 3D software will create our new drawing. So right now we have drawing 2 created. So this is just a default numbering that all Autodesk softwares use. And after that, we can now specify some of our settings. So navigate to settings tabs, click on this once, then right click on drawing, navigate to edit drawing settings, and this pop-up window will be shown. So from here, we have our units and zone. So you can specify your units. If you're using metric, you can use meters. If you're using imperial, you can use feet. So for our case, you're using meters. And then you can change your angular units if you want. You can actually change the zone that you're working on this. So for our case, we are working in Africa. The zone is around ARC 190, UTM zone 35, 37. So you can actually change this in accordance to where you're working. Let's say, for example, if you're working in the USA administration, you can click on this and then you can specify your coordinate system from here. So let's say something like this. So for our case, this project is actually found in Africa, specifically Kenya, and we're going to use the ARC 1960 zone 37S. So click on that once, and all this data will be auto-populated. After that, you can check the transformation, you can check the object layers, you can also check the abbreviations. So these are basically the descriptions. Let's say, for example, if you want to know what the alignment beginning point is actually defined by BP. If you want to know the curve end is actually shown by EC. So that's the way Civil 3D uses the data that it has. You can also check the ambient settings, but for now, we're going to leave each and every other item as is, and we're going to simply click on OK. So after we have defined our settings, we're going to navigate back to the Prospector tab. And if you're interested to learn all about these commands that you can see here on all these tabs that we have here, I have gone through them in detail in the free course that I have attached below. So we want to actually insert our points, and it's very simple. We're going to navigate to the points option here. And if you cannot find this menu bar option, so simply click on this drop down option, navigate to menu bar. So for your case, maybe it looks something like this, but you want to show it. So simply just go to show menu bar. And just like that, now we have this option. We also have the same option here, but these options are usually easier to reach to. Let's say, for example, if you're in the view tab, it's so easy still to get to this crucial option that we want. So for this case, we want to import the points. So navigate to import points, click on this once, and we're going to navigate to the folder that we have that file saved. So for my case, I have saved it here. So I'm going to select this item. I'm going to click on open once, and you have to make sure that you specify the format that you're going to be importing it. Remember, ours is a PENZE. There's also a PNEZD. So if you were to interchange this, it's actually going to make your project somewhat be like upside down, but we don't want that to happen. So we want the points, we have the eastings, we have the northings, we have the elevations, and also have the row description. So after doing that, we're going to specify a point group. So for our case, in this specific template, we already have a point group already predefined, but you can always create your new point group if you prefer doing that. If you also want to use the advanced options, such as to do some adjustment and transformation adjustments, you can also do this. But for my case, I prefer not to, so click on OK. And just like that, we now have our points import. So simply just double click on the center wheel mouse button to use the zoom extend option, and we can simply see our beautiful points that we have imported, and you can see the description keys that we have here. So after doing that, we're going to create our surface. So how to create the surface? It's very simple. Under the Home tab, we have the Surface option, which you can actually click on this drop-down option and you can navigate to create surface. Alternatively, we have the same option from Surface. You can create surface. Not only that, if you're to right-click on this option here, you can also navigate to create surface. And something really amazing about Civil 3D is that it's actually organized in a systematic order. So if you start with points, you navigate to surface, then you go to either surface, feature line, or you go to alignment, then to vertical profiles, then you go to corridor, intersections, assemblies, so on and so forth. So for our case, we want to create our surface. So right click here, click on create surface ones, and this pop-up window will be shown. So from here, you can specify the type of surface that you want to use. For our case, we want to use the thin surface, which is basically the triangular irregular network surface. So click on these ones, and then you can change the name of your certain layer from here or your certain surface from here. So just double click and just give it the name that you prefer. But as an engineer, you have to label your objects in accordance to the standard that every single person will understand. So for our case is existing ground. And you can also change the layer that you want to use. But for my case, I prefer using the default layers. Remember, Civil 3D usually creates layers by default that you can use for your project. You can also give it a description and you can change the style that you want to use. So maybe 2 meters for minor and 10 for major, or you can use 1 meter, 5 meters, so on and so forth. For my case, I am satisfied with this option. So close. And for the render material, you can use, let's say, gravel, grass. For our case, we're going to use grass, then click on OK. So right now we have created a surface, but we cannot really see it. But if you check on our Prospector tab, we have this plus button. So if you're to click on plus, we can find that we have the shell here, the existing ground, but it's not visible here. So we basically need to define the point group so that it can be connected to the points that we have here. So we're going to simply navigate to the point group under definition, right click, click on add, then we're going to select NYS points, click on apply once, then click on OK. And just like that, now we have our surface created. So we can see that we have our surface area here, moving all the way from this point all the way down up to here. And if you wanted to change any settings about the surface, you're going to simply click on it once, navigate to the surface property. After this contextual ribbon pops up, which you can actually see that it's the thin surface existing ground. So click on this option once and this pop-up window will be shown. So before even changing the definition, we're going to navigate to statistics.
Now, before we move any further, I'd like to share with you our completely free Civil 3D Essentials course with you. If you are new to Civil 3D and want to learn it in a step-by-step way, right from scratch with a certificate of completion, then here's the course for you. It is linked in the pinned comment and also in the description. You can start right now with a simple sign up and your access to course will remain active forever. So it's never going to expire. So get started with Civil 3D Essentials course now and I'll see you in the course area. Now back to the video.
So under statistics is where we can see the maximum elevation that we have. So let's say the maximum elevation that we have here and the mean elevation and the minimum elevation. So for our case, we're gonna play around with these areas. We're gonna set some parameters that Civil 3D will be using to create this surface boundary. So we're gonna use the minimum being 1100 while the maximum being 1400. So what do I mean? We're going to navigate to definition, click on build, and under exclude elevations less than, we're going to change from negative 1000 meters, which is basically 1 kilometer. So we're going to update this to 1200. And we're going to also create this parameter exclude elevations greater than. So we actually want to use 1400. Click away. And for the maximum angle, this is actually important for triangulation. So we're going to create a parameter. For the maximum angle, we're going to use 135 degree. And for the maximum length of the triangle, we're going to use something like 100 meters. And that being said, everything is all right. Then click on apply. We're going to be prompted either to rebuild or to mark the surfaces out of date. So simply click on rebuild so that we have the real-time update. So after we have that, you can actually change some items that you want. So let's say we click on OK, and I want to change the style that we have here so that we see the boundary. So I'm going to click on this drop down, navigate to edit surface style, and I want to show the boundary. So turn on this visibility of the border, click on apply so that we see how our boundary of our surface looks like. So if I zoom out, this is the boundary that we have. So the most important thing that we want the center line to be covered within this boundary. And we can see that the center line is actually getting to around this point, while this other area, we do not have the center line data. So if we zoom in, we can see that everything seems to be fine. So after we have confirmed everything is all right, now we can turn off the boundary and we can actually start to create our horizontal alignments. So let me turn off my boundary, my border from here, click on apply, then click on OK. But remember, you can change so many items that you prefer to change from here. Let's say, for example, we wanted to add some contour smoothing. If I click on this, I can change this to true, and I can be able to increase my contour smoothing. If I click on apply, you can see it has become more smooth. If I was to decrease it, you'll see that they're more sharp. So that is basically what usually happens with contour smoothing. So for now, I'm not quite going in depth with all this information, which is still quite important because we have already gone in depth in the course that we have in the description below. So I'm going to navigate to home. Then I want to create our alignment. So how to create our alignment is very simple, either from here. So if you click on this drop down option, we have our alignment creation tool, or you can find the same option from here. So click on create alignment by layout. So click on this once and this pop-up window will be shown. So from here, we can specify the name of the alignment that you want. So for this case, let's say we use the name source code to be the name of our alignment. So we actually want to create the center line, which is CE. So specify center line. We have so many other options such as rail, curb return, so on and so forth. And you can give a description if you prefer. Then you can change where the chain edge is starting. So this is basically the chain edge, and we can start at chain edge 0 plus 0, 0, 0. You can also specify the site. So by default, Civil 3D creates a site for you. So for our case, you can even leave it as none. It's not an issue. Then you can specify the alignment style that you prefer. Remember, if you want to change the alignment style or edit it, you can edit the current selection, or you can copy the current selection and do some changes, or you can even create a totally new style. So for our case, I have already created this duplicate, and we're going to use it for this case. You can also change the labels that you want, either the major, the minor, the geometrical points, or you can also add all of them. But for our case, just leave them as is, as well as the layer that will be used to create the alignment. You can also specify the design criteria. This is basically the speed at which the vehicles will be moving along this specific alignment in accordance to AASHTO. But for our case, I won't be going in depth about this specific area as we have already covered it in the course below. So click on OK once, and this alignment layout tool will be popped up, and we want to create our alignment from this point all the way to the very edge. So we're going to use the turn, no curve. So click on this once, and the command is now active. For you to select a certain point, you can make sure that your node option is checked, this option here, or alternatively, for pro users, you can also use this select object option that is usually found here. So if you want to use this, you can also select this. But for my case, I just prefer using the normal way. So from this point, I'll create my first alignment, and I'm actually eyeballing. So you see those lines over these points over here, I want them to be in this tangent. So let's say around somewhere here, as well as these other lines around here. So this one is not going quite as I wanted. So I'm going to just zoom in and place it there, then right click just to move away from the command. So I have this point of intersection here. So I'm going to click on it once so that I move it, and I'm going to eyeball it so that it actually touches majority of the center line points that we have on this other side, as well as checking at the bottom area to make sure that I do not miss them. So right now we have some points moving or being touched over here by this tangent as well as this other side. And you might wonder, what are we doing? So we actually want to create a simple curve from this point all the way to this point, and we are going to create from these two entities. So I'm going to navigate to the Home tab, and I'm going to select the arc option, which is the start end direction. So click on this once, click on it to activate it, and I want the curve to start from this point and end at this point here. Then I'm going to zoom in a bit and place it around there. So once I have the arc or the proposed curve, I'm going to select on it once, hover my cursor over this area to know the radius. So we can see that the radius is around 308. So after that, I'm going to simply navigate to my alignment tool, layout tool, and I'm going to select the spiral, curve spiral. So we have the spiral, which is this one, then a curve, then a spiral. That's why I'm selecting this option. I'll select my first entity. Remember, our first entity has to start from change 0, moving to the incremental area. So this is the first entity, the next entity being this one, and the solution of the angle is less than 180. Always select less than 180. Then I'm going to specify the radius being 308. I'm going to hit on enter once, and I'm going to give it a solution for the spiral length. So much of the time we usually do radius divided by 10. So we can try 30, hit on enter once, and we can see a proposed solution here. And the spiral out, I can also use 30, then hit on enter, and just like that, right click to move away from the option. So we can see that our curve is not exactly at the center. How to correct this is rather simple. Just click on this option here that we have, and the panorama window will pop up. If you select on this, it's gonna be highlighted that you can actually edit it. So let's try to use 300, then click away, and perfect. So our radius is actually 300. And if you select on this curve that you already have here, that you do not need anymore, you're gonna simply just click on erase. But always make sure you select the curve alone. So just hit on escape a couple of times, then select it, then click on erase. Just like that, it's gone. So we want to do the same for this alignment over here. Just create our alignment. Let's say from this point that we have the center line, making sure that it's a straight line up to, let's say, around here, something like this. Then I'm going to right click just to make sure that now our lines are okay. So this is actually a problem that I want to show you the solution. So we have two alignments here, and we have a very minor point of intersection. It means that there's no point of this point of intersection. This alignment can go straight without any issue. So how to do away with this? It's very simple. So simply click on this option for delete point of intersection, then select at that point, and just like that, it's already deleted. So we actually want to create a solution for this error here, and it's quite simple. So if you're not satisfied, you can actually undo from here just to take it back, and you can create your radius. So remember, click on this option. So we want our start point. Let's say our start point being here, our end point being around here, and our direction being around this point here. So if you were to click on this radius, I know the radius will be very large. It's around 1614. So let's zoom in and create this specific curve. So click on this first, and the next one being this one, less than 180, then specify being 16, 18, hit on enter. We're going to use 5 for now, and we already have a solution here. And the next one, we're going to use something like 10, then hit on enter, then right click. And now we can do away with this curve that we have here. Select it, click on erase, and just like that, now we have our alignment. So that's the way we actually create the alignment for all these other points. But for now, I'm going to simply delete them. So to delete our points, we have to be very careful. You can see that we have our surface here that we first need to hide. But how to hide it? We're going to go to our surface property, and we're going to select at no display option, which is found here. Then click on OK so that we hide it. Then we're going to double click on escape, and I'm going to select all these points that I do not want to use for now because I want to focus on how to create our quantities. After on there, I'm going to zoom in just to select my spot height. And after I'm done with that, I'll navigate to home. Then I'll navigate to erase once. And just like that, we have our points erased. So after we're done with that, I'm going to simply click on close. And then I'll navigate to points. You'll see this error here. So click on it, right click, navigate to update. And then you'll see this error here. Simply click on this, right click, navigate to rebuild. And just like that, now the error is gone. So the next thing that we're going to do, we're going to offset this specific alignment that we have created. So click on this once, navigate to the contextual ribbon where you'll find the offset alignment. So once you have this option activated, you'll see that you can select from the list of alignments that you have. For our case, we have only one. So select it. And the name of the offset will be basically the parent name, which is the source card center line, with the side, which is either left or right, and the distance, which is either 3 meters or 5, depending on the design that you're working on. So for our case, it's 3.5, and the number is only 1. And you can change the range from here, but we want to start from start all the way to the end. We can also specify the style that you want. So basically, we're using offset, but you can even edit and specify the one that usually resonates with you. For the labels, we do not want any labels. For the widening criteria, we're not going to be using this at this stage, as well as the create profile option. So once you have this selected, click on OK once. And just like that, now we have our offset. I'm going to click on escape just to move away from that option. And the next thing that I want to show you how to do is to create our profile. As I told you initially, Civil 3D is created in a sequential manner. So we are from points to surfaces. After surfaces, we have done our alignments. So now what is remaining before creating our corridor is actually our profile. So click on profile. You can either create your profile from here or create your profile from here, from surface. Let's say we click on this option, this pop-up window will be shown where you can specify your alignment. For our case, we have this alignment and the two offsets. So we want to focus on the center line alignment. So click on this ones, and the surface is the one that we have created here, which is basically the existing ground. So we actually want to create the final ground level, and that's why we are creating the profile. So specify the surface that we have now. So it's the EGL. Then we're going to specify where to start. So we actually want to start all the way from the very beginning to the very end. Then click on add, and it will be added down here. Then click on draw in profile view, and you're going to specify more information such as the name, which will use the source card center line, which is the parent name, and the next count, either 1, 2, 3, so on and so forth. You can also change the style that you'll be working with. I usually prefer using the full grid 100, but remember, you can always create a new one, or you can even edit the current selection or copy the selection and edit it. After that, you can also show offset profiles, but all this I have covered in the course below. The same thing with the station range, leave as automatic. This one leave as automatic. This one I'll show you at a later stage, but just leave everything as is. Go to next. Under the band, the data band, you can select the full band set, or you can specify the one that you prefer. So just leave it as a full band set. So this is basically the information shown at the bottom or at the top. So you can change from here. Top, you can see this blue line here. Bottom, this blue line here. So just leave everything as is. Or if you want to change, for my case, let's say I want to change something about it. It's very simple. I'm going to simply click on edit the current selection. Let's say I do not want to show the basic style of the vertical geometry as this. I'm going to click on that option, and I'm going to select geometry, then click on OK. The same thing, let's say with the horizontal curve. If I want to just show the geometry, I'm going to click on that. The same thing with all the others. So for now, I'll just click on OK, and it will be updated as you see here, and then I'll click on next. So for the hatch, this one comes in handy when we have the cut and fill information, which I'll be showing you at a later stage. So click on create profile view once. then specify where you want to place it at the bottom left corner of the chart. So place it here, and just like that, now we have our vertical profile. It's very beautiful. So we actually want to create the final ground level, and it's rather easy. So how to go about it? So navigate to profile, and we're going to be creating our profile from the layout. So this is a layout that we already have here. So click on this once, and it's going to prompt you to select a profile view to create a profile. So this is the profile view. So click on this once, this grid option, and this pop-up window will be shown. So from here, we can give it a name. And for our case, we actually want to name it as the final ground level. After that, you can give it a description if you prefer, and you can also change the style that you'll be using here. So for our case, we'll be using the FRL, which is basically the final ground level. And you can actually specify the design speed of this specific area in accordance to AASHTO, but I won't be going in depth about this information in this video. You can also specify the label set that you'll be using. So you can use it as the complete label set, or you can specify the one that you prefer from here. After that, click on OK. And this pop-up window will be shown, which is basically the profile layout tools, and most specifically for the FGL level. And just like we were doing for the horizontal, you can do the same for the vertical. So click on this option once, and we can specify our start point. So our start point can be, let's say, from around here. We can see the difference from this point to this one point is 1 meter. So if we were to start from around here for our final ground level, remember, we don't want to have a lot of cut and a lot of fill, and we do not want so many curves within our drawing. So we are targeting where we can have smooth transitions with less cut. So let's say from around here, then I'll try to eyeball the next point. Let's say here we have a lot of fill material, but I'll show you how we actually correct that later on. Then from that point, we're gonna eyeball to the next point. Let's say it's gradually moving, descending up to around this point here. Then from that point, I'm going to try to eyeball to the next point, which is basically at the very edge. So zoom in and place it there. After we are done that, right click to close away from the command. So where we have this point is basically where our software tells us that we have our point of intersection. So what do we do about this? It's a ground break. So we need to provide a simple curve, and it's very easy. Just navigate to this option here, and we're going to select this free vertical curve parabola. So click on this once, and we're going to select our first entity. Remember, from chain at 0, moving in incremental. So this is the first entity. The next entity being this one. And you can specify either the curve length or the K parameter or the pass-through. So you can see this over here. So by default, we need our length, our section length over here, or our curve length has to be greater than the design speed or equal to the design speed in accordance to the standard that you're using, or has to be 2 VD, has to be twice the design speed. Let's say, for example, we're using a design speed of 60 at this section, so the length has to be around 120 to 100 and greater than that. So let's say we use 125, hit on enter once, and just like that, we have our first smooth curve. Now let's select the second one. So this is the first entity. So zoom in slightly to select it. The next entity being this one, and then the same philosophy applies. So 122, hit on enter, then zoom into this other section here. Select the first entity, then the next entity, then the curve length, let's say 150, hit on enter, and just like that, just right click, zoom out, and we can see our curves. They have been made and they are quite beautiful. So I want to show you how we can make even our graph more beautiful. So simply click on this graph area that we have here. I'm going to move this one slightly on the side. Then navigate to the profile view properties. Click on this once. And under this, you'll find these options. So under hatch, we want to create the cut area, which is basically the area that will be cut from this section because it's above the final ground level. And the upper boundary is actually the existing surface, while the lower boundary being the final ground level. That's why there's a cut. And you can change the style that we have here by selecting from the list that we have here. But if you're not satisfied, remember, you can always create a new one. Let's say we have solid. I can call it maybe solid color or something like that. The display, we can change the display from here. Right now we're working in the model. So if you want to change the pattern, you can specify the solid fill here, and you can change the color if you prefer from here, or also in the plan, you can also change it from here. So you can do so many things that you prefer from here. After doing that, you can click on OK, then you can click on OK, then you can add the fill area. So basically where the upper is the FGL and the lower one is existing ground. And then you can simply click on apply, and you can see that we have this gray color because that is the color that we are using here. So navigate to display, and we're going to change the color just by clicking on this. Maybe the cut area we want to use red. So just change the colors from here. It's rather easy. So we're going to update for all of them, as well as the profile, the section as well. And after we're done with that, click on apply. And just like that, we can see it has updated here, because this is actually more or less like a section. If you want to edit for the fill as well, you can always create a new layer. So under this, we can change it as fill solid. Under display, we're going to start with, we want to change the profile one to be specific. So this one we can change to green. Click on apply, then OK, then apply. And now we can see where we have the fill area, we can have the green color being shown, just like this. So that's the way we make our presentation even better. After doing that, we're going to simply click on close, because now we are done with the creation of the vertical profile, and we'll be focusing on creation of our corridors. So remember, we can either access the same option from corridor over here. So if you click on this, you go to corridor, you'll find this option. Or if you click on corridor here, you'll find the option of create corridor from here. So once you click on this option once, you can give it the name that you prefer. Let's say the Yatta main road, or even something like, depending on the design project that you're working with, because we're already using source code, we can use the source code road corridor. After that, you can give it a description, you can give it a corridor style that you want, and you can specify the layer. So I usually prefer using the default layers, which you can already see here, it's corridor. Then you can specify the baseline type, either an alignment and profile or a feature line. So for this case, you're actually focusing on the alignment and feature line. Then you can specify the alignment that you have. If you have multiple alignments, you can select from this list. Or if you have multiple profiles, you can select from here. And for our case, we actually want the corridor to be on this final ground level and not be on the existing. So select the final ground level, and the assembly is basically the elements or the parameters. Let's say the curbs, the drainage, the ditch, so on and so forth, that will be used to generate the quantity takeoff. So for now, we have not defined any assembly, but that is on purpose so that I show you that you can actually come and define your assembly later on and still get your quantity takeoff. So after doing that, make sure you do not check on this option. I just want to leave it as is, then click on OK once. So it has said that the source code road corridor has been successfully generated without any defined regions. So just click on OK. And if you zoom in, you'll not find any change. This is because we do not have any assembly defined within our drawing. This means that even if you have your corridor created, it can still be within the model, but it's not really visible because the assemblies are not there. So now let's create our assemblies. So you can create your assemblies from here, or if you navigate to corridor over here, you can still click on create assembly. So click on this once, and we want to give it a name. So let's say for this case, we are designing for carbs. So let's say carbs, typical, and you can give it a description, and then you can specify the type of road that you're using. So I've gone in detail about this in the project cost that I have already attached down in the description. So for our case, we're using the crown road, which has mainly two ifs, which is undivided. And then you're going to select the assembly style. So either basic, so I'm going to leave it as is, as well as the style, I'm going to leave it as is over here. And I'm going to click on OK, with the layer being the default from Civil 3D. So click on this once, OK. And then I'm going to specify the base location. So around here, because you know the assembly will be very small. So just after clicking once, this assembly will be created. If you're actually interested on learning how to create this quantity takeoffs in a step-by-step manner, I have already attached a complete article on how you can be able to create your quantity takeoff down in the description below. So right now we already have our assembly. This is basically the source point which connects all the sub-assemblies and creates it to be something meaningful within our software. So I'm going to click on this once. And after clicking on it, we'll have this contextual ribbon where we can be able to add some sub-assemblies. So where are these sub-assemblies? If I was to navigate to the Home tab, you'll find this option toggle on, which is basically our tool palette. For your case, if it's off, you will not find it here. So let's toggle it on. You can either find it here or you can find it under the View tab, and it's still found over here. So if I was to hover my cursor over this, I will find all these options. So for my case, I can see all the tabs, but for your case, the tabs might be overlapping, which you'll just click on the overlapping tabs and the sidebar option will be shown. So for this case, we actually want to create curbs, but before creating the curbs, we need to place our lanes. So navigate to lanes, click on the lane super elevation A or R. So click on this once. And once selected, we'll have our properties tab popping up. And from here, we can actually specify some parameters such as the width of the road, which side the road is being sloped, so on and so forth. So remember, these are very key parameters which we actually use for our quantity takeoff. So pavement 1 being, let's say, the AC. Pavement 2 being the binder. The base being a certain thickness, the sub-base being a certain thickness. So by defining all these parameters is only when we can be able to get accurate quantity takeoff. But do not be worried. You can also place your sub-assembly and you can define your thickness of the layers after the design has ended. So if I was to place my sub-assembly, I was just to click on this line, this straight line once. So click on this once. And just like that, the left has been added. If I click on it again, the right will be added. If I click on escape, it will close off from that setting. But if I was to select on these items that we have here, I can navigate to properties. So click on properties once, and the properties option will pop up, which shows us that we have selected two sub-assemblies where we can specify the width. Let's say we want it to be 3.5. We want to change the default slope to negative 2.5. Remember, it's negative because it's falling. We can specify even the pavement thickness, pavement 1, which is basically the AC. So it can be 0.03. We can specify the thickness of the binder material. So this is all right. We can specify even the base depth, which can actually be 0.12. So depending on the design standard that you're using, and you can even leave the sub-base being 0.3 meters. After you're done with that, you can just simply click away, then hit on escape twice just to move away from that. And you'll notice that if you're to edit these parameters, they're being updated in real time. Also the thickness. Let's say, for example, if I use this as 0.9, if I click away, it will be updated in real time. So this is 0.3, just like that. So the next thing that we want to add over here, a sub-assembly, is our curbs. So I'm going to navigate to the tool palette, then I'll navigate to the curbs. So click on curbs once, and we're going to use the first one, which is the urban curb gutter general. So click on this once, and just the same thing. You can specify the type of dimensions that you're working with, the slope, as well as so many items that you want. So we're going to first place our curbs. and you're gonna click on this first ring over here, this red ring. So click on this once so that you connect the top AC level. The water will flow from this point, moving towards the curb, and then from the curb you can either have a French drain where the water will go down, or you can now direct this to a certain drainage system later on down or downstream. On this other side, I'll just click on the same ring. So click on this once and then simply click on escape. So I'm gonna select these curb items that we have defined. So you can actually edit one by one. So let's say, for example, this one is negative 2.5. They have to marry one another. These properties have to marry with these properties for best engineering standards. And we can change the subbase depth so that we have them matching. So from this area, we want to increase this to 0.35, then click away. So this is actually the width, the extension, and we want to change the slope to negative 2.5. So 1 negative, then click away. And we want to increase the depth of the subbase, or 0.475. Depends on what you want to use. So we can actually do the same for this other side. So if I was just to click on escape once, then I select on this, we'll do the same for this other side. So negative 2.5, 0.475, negative 2.5. Then we can also change the extension to 0.35. And just like that, now we have the parameters set for our sub-assembly. Not only that, we can actually create multiple sub-assemblies. And it's very simple. We can simply just select this and we can actually copy. So you can use CO on your keyboard to activate the copy command. Hit on enter once, click away around here to specify the base point, and we can turn on our ortho mode so that we have it created on an ortho mode. And then we're gonna change the sub-assembly that we have here. So just zoom in slightly. So for now, I want to do away with this specific sub-assembly. So I'll select this and simply just delete it. No issue whatsoever. The same thing on this other side, select, delete it. After that, I want to specify the sub-assembly on this side. So I'll navigate to the tool palettes and I want to use the ditch for this case. So click on trench, navigate to side ditch with lead. So click on this once and you can just specify the marker point. So this is a point. So the water will be flowing from this point down into the ditch over here. And you can also specify so many other items that you prefer. Let's say for your case, maybe you're working with daylight. So daylight is basically the soil that is found on the side of the road. So you can specify a basin, something of the sort. You can click on this, or you can go through all these specific options that Civil 3D offers to you as a civil engineer. We can also work with retaining walls if you prefer. So if you go to this option, you can specify the type of retaining wall that you have or the rebar that you want, or you can also specify a new rehab, or you can specify a bridge if you're working with bridge or also with rails. So for this case, we can specify just the daylight, click on the basic one. You can go through the options that are given here. Remember about the slope and also the thickness. So click on this ring over here once. And just like that, we now have our daylight created on this side. After that, I'm going to right click, click on enter, then hit on escape to close from the command completely. Then I'm going to click on close to close from the properties option. After that, we want to specify these assemblies within our corridor. So simply right click over here, navigate to select. So click on select and we're going to go to our sub-assemblies property. So click on this once and this window will pop up. So from the information, we have already created this corridor. From the parameters, we want to specify the assemblies. So it's very simple. So under our baseline, which is our source card center line, right click on it and click on add region once. And under this, we're going to specify the assembly that we want. So we actually created a copy of the assembly, but we did not rename it. So first, close from here, zoom in to this specific assembly that we have. So this is the assembly, this center one. So we can see that the name is Cubs Typical 2. So we want to rename it to our ditch typical. Then I'm going to click away, and just like that, it will be updated. After that, navigate back to corridor. So I'm going to zoom out so that we have a picture of our corridor area. Right click, click on select. Once we have selected, we have this contextual ribbon. Click on the corridor properties. Then under this, right click, click on add region. So click on this once, and we're going to specify the region and the assembly that you'll be using. So we're going to start with Cubs. Click on OK. Click on this plus button, and you'll see that it will be added down here, but we'll have this warning sign. So this is basically important that we rebuild the corridor because we have added a new type of assembly. And you can specify where this assembly starts and where the next one will start. So we're going to click on endpoint. So I'm going to zoom out and maybe place my endpoint around there. And just like that, it will be updated. Then I'm going to click on the baseline, right click, click on add region, then specify the ditch typical, click on OK once, and just by default, it will pick from the end station to the start station of the next one. After that, we need to rebuild our corridors. So what will we do? We're going to click on apply once, and this option will be shown. So we're going to click on rebuild the corridors, and just like that, you can see something has happened in the background. So I'm going to click on OK. And if I was to zoom in, you'll actually find the significant illustration where we have one certain assembly which moves from start up to this point, while the other one starts from this point, moving all the way to this other section. So if I was to click on this item here, you'll see that we have our corridor, which is basically a corridor created. And if I navigate back to the corridor properties, we do not have any errors whatsoever. You can also change the frequency that you want to create your corridors at, but at 20 meters is sufficient with me. Under codes, you can specify the codes that you want for each and every single item, but I won't be going in depth about this. The same with feature lines, but under surface, this is very important because this is the area at which our software takes this data and creates the quantities from our corridor. So we're going to first create our surface for our corridor. This is specifically for a corridor. So click on this once, and we have our corridor surface created here. So under it, we want to create our specific data, which is basically our top area. And we're going to use the links to create our top area. So click on top and the bottom area. So under top, we need it to act as a break line, and we need the overhang correction to be the top link. We need also to rename this surface to make it easy for us to understand to be top. We're gonna create a new surface, so click on this once, and we can rename it either to bottom or to the base, depending on what you prefer. So for our case, it's actually bottom. Then I'm gonna add another data type here, which is actually just the base. So click on base or the data. So click on data and add it down here. Then click on check. So just to make sure everything is the same, so we're gonna just update this to data. Then I'm gonna click on away. I'm gonna change the overhang correction to the bottom links. After that, I'll navigate to boundaries, where now we have our top boundary and the bottom or our datum boundary. After that, I'm going to click on apply, then OK once. So after doing that, you'll see that we now have our surfaces which have been created within our corridor. So the next thing that is actually remaining is quite simple. It's just creating our sample lines. So our sample lines are actually found under Home tab. And as I told you before, everything is organized in a systematical order. So we are done with assembly. So we want to create our sample lines. So click on sample lines once. Click on an alignment or press on enter to select from the list that we have. So we want to create for the center line alignment. Click on OK. And we're going to go through these options that we have here. So this is basically the sample line group. So the name can vary. Let's say for this case, you can use the source code SL, which is basically the sample line. You can specify the type that you're going to use. So I'm going to leave everything in default, inclusive of the layer. Then after that, I'm going to make sure everything is sampled. So make sure everything is sampled. If some items are not sampled, we're going to have some error in the quantities. Let's say, for example, let me uncheck this too, so that you understand what I mean. Click on OK. And the next thing, do not click on anything. First, you need to change the type of station, range, or selection that we're going to be using. So we're going to use by range of station. Click on this once, and this sample line creation by station range will pop up. From here, you can actually specify where the sample lines will start. Let's say from start, true. From end up to the very end, true. And if you want to use the left swap width, you can specify from here. But for now, asphalt, and the width distance offset is 20 meters, 20 meters. And this is basically how far is the text from the center of the sample line. So if you actually want more control points, maybe at a specific super elevation or a critical area, you can specify as true. But for now, we're going to leave everything else as is. Click on OK once. And just like that, you'll see that our sample lines group have been created. But I do not want to click anything else. After that, we're going to simply click on close. So after you close once, you'll see our sample line groups have been created. The important thing about the sample lines is basically a region which the software uses to calculate the data or the quantities within that specific zone. So for our case, we want to do a very simple edit. So we're going to click on one of the sample lines. So if you click on it, this pop-up window or this contextual ribbon will be shown. And I want to edit the sample line properties. And you can check the information that we have about a specific item. But I want us to check about the group properties. So all of them in one. So we're going to navigate to the sample line. And under this area, I want to extend the left offset. I'm not going to do it one by one. I'm going to simply click on the first one, scroll down to the very last one, hold down my shift key, click on this one, let go of my shift key, then click again inside. And I want to give this, let's say 30. Then I'll click away. And just like that, you'll see that all of them have been updated. So I want to do the same for the right offsets. So I'm going to select the first item, holding down my shift key up to the very top, then let go of the shift key, select this, let's say 15, then click away, and just like that, all of them have been edited. We can also change the sections that we want, or the section views if we want, or the material list. So this is the next item that I'll be showing you about. But before that, click on OK, and just like that, the edit has been created. So if you zoom out, all our sample lines have been created and they are beautiful. So the next thing that I want to show you is about the material list. So we're going to navigate to the settings, and under settings, we have our takeoff. We have our quantity takeoff. So click on this plus button once, and we have our quantity takeoff criteria. If you click on this button once, we have these criteria that are already defined over here. So if you want to add a criteria to yourself, right click, click on create new, and you can specify the criteria that you want. Let's say, for example, we want the source code quantity takeoff criteria. You can specify the material list that you want it to be added here. So we're going to add a new material here. So let's say, for example, this material that we are working with is the earthworks. So earthworks, then click on away. So this is basically earthworks. So click on earthworks, where you can specify the cut factor. So this is basically the amount of shrinkage factor that we have for that material. So you can use maybe 0.9, depend on the type of material and the type of region that you're coming from. And the fill factor, maybe 1. And then you can specify the shape if you want from here. And after that, we're going to add our data type. So for our case, this is basically the surface. And you're going to specify the top and the bottom. so that the software will know which regions to cut from. So let's say we want the existing surface, click on add. So this is basically the base, and you can specify also the bottom. So we're going to use the datum, then click on add, and this is basically the base, and this is the base, but this we're gonna define later on. So define the sample line group. So we're gonna use a sample line from source code, click on OK, click on apply, then click on OK once. So after doing that, it will be added to this list, and I'll show you where we're gonna be using it. So going back to the prospector tab, we want to create our quantity takeoff. So simply select on any of the sample lines that we have, navigate to compute materials, and under this is going to ask you to select the alignment as well as the sample line group, which we have already created. So click on OK once, and this pop-up window will be shown. So remember, we already created a certain criteria, which is basically the source code, and we have it here. If you click on map objects with the same name, you'll actually find that we have an error here because some of them have not been defined or have not been picked. And even if you try to click on OK, our Civil 3D software will give you a warning. So what is the problem? So it's very simple. We're going to click on close, and we're going to click on sample more sources. So click on this once, and you'll find out that these items that we did not add to our samples are actually what is causing the error. So click on this add. We're going to add all of them. Click on apply, click on OK. And if we go back to our compute materials, so click on this once, still the same option, click on OK. And even if you are using the cut and fill, if you click on map with the name, so we're going to specify the existing ground over here, as well as the datum. So this is the datum over here. And if you're to click on OK, just like that, now there's no error. And now we have some quantities. So to see these quantities, simply click on Generate Volume Report. So click on this once, specify the alignment, the sample line group, the list, the material list. So currently we just have one, and you can specify even the sheet style that you're going to use. So for our case, we want only earthworks. So click on this once, click on Open, then click on OK. So just after a few seconds, or depending on the size of the project that you're working on, the report will be generated. So for our case, this is a report that we have here. So this is basically our cut area and our cut volume and the reusable volume. So for Civil 3D is a very efficient software, which actually assumes that everything that you cut is everything that you're going to reuse. But as we know as engineers, this is not always the case, but the design philosophy from Civil 3D is really good. And then we have the fill area. Remember, we have some areas to fill. So you can see the fill area as well as the cumulative cut volume, as well as the reusable volume, all of them cumulative. And if you scroll all the way down, you have it here. So after you're satisfied with this, you can actually now generate more quantities. So navigating still under compute materials, specify the alignment that you want, click on OK. And this time we actually want to create our list focusing on items such as our pavement. So how are we going to go about this? We're going to just simply click on import another criteria. I'm going to select the source code Qt. And for now, I want to edit it because remember, when you are defining it, some elements were not sampled. So under this, I want to change some information. So I'm going to just simply click on delete, and just like that, it will be deleted. I want to add a new material. And in this case, I want to create some paving material. I'll click away. I'll change the type to structures. So click on structures once, and under the data type, we're going to select the corridor shape. So under this, we want pave one. So click on pave one once, and this is just pavement material, and we want it to be included. We're going to select pave 2. So this is basically the binder. Then I'm going to click on a new material. So under this is actually the base. Type on base. The material is structure. Make sure you update this structure, yeah? Then select on base ones, click on add and include. So the next material that I want to create is for the sub base, which is this one. So I'm going to click on new material. I'm going to enter a sub base. And let me show you something cool. Even if I did not change this and I wanted to add the sub base, I'll actually be given a warning on Civil 3D. So the Civil 3D is very smart and it's actually going to realize that there's an error happening over there. So the next material that I want to create is actually for the drainage and the curb. So I'm going to create a new material, which is just basically first the drainer. It's a structure. Now I'm going to add the ditch as well as the lid. Then after that, we're going to add basically our curb. So this is the curbs. Remember, this is a structure. So select curb, add, just like that. And if you want to edit, you're going to just do away with that. And just like that, you're going to define our sample line groups. So this is our sample line alignment, which is our source card. And the sample line group is our source card SL. So click on OK. After that, we're going to simply check if everything is all right. After being content, click on apply, click on OK, then OK. Then everything will be loaded up here. Click on map to existing with the same name. And we can see that the existing ground is this one. So click on that one. The datum is this one here. Click on datum. And the top is basically this top. It's already picked. And for the pave material, all of them have been picked accordingly. Click on OK. We have the computing of materials going on over here. And you can click on this plus button so that we can see what has been added. And you can actually change the name from here. So let's say this is for a certain company. Let's say for this case is source card has been contracted to create this material list. So source card material list. And we have all these materials being shown here. Remember, we can also change the cut volume and the factor that we want to use from here. So these are basically the cut or the fill. So it depends on what you want to show. And if you want to do away with any of this material, let's say I want to do away with this, it's very simple. Select on that one, and then you're going to simply just delete them because remember, we want to just show for the structure in this case. So just like that, they're all gone. After that, we're going to specify the type of method that you want to use for calculation. There are mainly three. The first one being the average and area, which is basically the one that I prefer because it usually takes the top and the bottom, and then it gets the average and area for those quantities. The second one being prismodial and the composite volume, which I've already covered in the course that we have linked down below. After doing that, we're going to simply just click on apply, then click on OK. After our software runs the analysis and the computation, we're going to go to create volume report. So click on this once. And in this case, we need to specify the list being the source card material, then click on OK. And just like that, you'll actually realize that some of our values are actually 0 because we did not change the style that we were using. We still use the earthwork style. And for now, we actually want to generate the volume for our source card list. So navigate to source card material list, and we're going to change the style sheet to select material. So make sure you double click on this once, or if you just scroll, you'll find that we have the select material option style. So click on OK once. And just like that, now we have our report created. And you can simply see that we have our station 0 having our paving information, our base information, our sub base, our drainage, our curb, so on and so forth. And it has actually given us all the stations from start all the way to the very end. And if you actually have this in Excel, it's very easy just to use the areas that we have to find the quantities of each and every single item. For example, the curbs and also the drainage ditches, covers, so on and so forth. Remember, from chainage 0 up to chainage around 478, we did not have any drainage. That's why we have drainage information from this area going all the way down. So that is actually the power that we have with Civil 3D. And if you actually wanted to have more detailed reports and more professional reports, you can find the same under the toolbox. So navigate to Toolbox. Under the Reports Manager, click on this plus button. Under the corridor, click on this plus button, and we have all these reports. But the one that we are most interested on is actually the volumes report. So right click on this, click on Execute, and the same thing, we're going to specify the material list that we want. So for our case, we are going to specify the volume of the earthen material. Remember, material list 3 was for the earthen material, and we have the alignment and the sample line group selected. You can also specify the start and the end station from here. So click on this browse option, and we're going to save our file in a certain format that we prefer. Let's say, for example, we want to save it as source code civil report. I want to save it as a HTML file or a Word file or a Excel document or a text document or a PDF document. You can save all this, the one that you prefer. So for now, I want to save it as a PDF, but you can also save it as a Excel document, which is really good. So click on this, click on save once, then click on create report. So after a few seconds, the report will be created. And from here, you'll find all the information about the cut area, the cut volume, reusable volume, so on and so forth. And you can actually create a tally down here, and you can actually use it to compute your materials over here and also multiply it by a cost factor so that you know how much everything will be costing. You can also change the name of the client. Let's say for this case, the client might be SourceCard, and the client company name might be something else, and the address might be something else. So from here is where we define all these parameters that we want. So after you're content with that, you're gonna simply just click on done, and we will be done with our quantity takeoff. Congratulations. So I believe now you understand and you appreciate how we generate our quantities in Civil 3D. So I have taken you through a step-by-step guide on how you first start your design in Civil 3D, where you import your points from Excel worksheets into your Civil 3D software. You create your surfaces, then you create your horizontal alignments. From there, you also create your profile, then you create your final ground level, and after which we created our corridors, then our assemblies, and from our assemblies, we defined our corridors with the assemblies, and we were able to generate our quantities. I've not only taken you through that, but I've also shown you how to generate our reports as a professional and how you can be able to transmit these reports in either Excel, PDF, Word, or any other format that you prefer. So having said that, it has been a pleasure taking you through. And the last thing that we'll actually do with this specific design, we are just going to save it. So I'll just navigate to File. Under File, I'll go to Save As. So I'll be saving my document under this as Quantity Takeoff Civil 3D Done. And I'll check on Update the Sheets and the View thumbnails now. Then I'll simply click on Save. So just like that, now we have our model saved and we can simply close from it.
So that was all about calculating quantity takeoff in Civil 3D. If you haven't yet signed up for the free Civil 3D Essentials course, then you can do it now using the link in the pinned comment and also in the description of this video. Also, let me know the topic you want us to cover in the next video. I'll see you in the next one.